Science communication isn't just about sharing facts. Honestly, if we just throw raw data and statistics at people, it usually bounces right off. Why? Because the human brain is fundamentally hardwired for narrative. But when we wrap that vital data up in a story, suddenly we activate empathy, we spark imagination, and we dramatically increase how much people actually remember. Storytelling is that essential bridge between a cold laboratory finding and a society that actually cares enough to change its future. So welcome to This Explainer. Today we're taking a cinematic journey and we're going to use the absolute best tools storytelling has to offer, specifically Pixar's legendary storytelling rules, to make some incredible science completely unforgettable. Pixar's rule number 14 asks, why must you tell this story? What's the belief burning within you? Well, today's story is about the awe-inspiring ways human innovation is quite literally reshaping our world, and exactly how you fit into that grand design.
So picture this. Imagine stepping up to a sleek metallic wall. Right in the center is this tiny silver door. What lies behind it? I want you to step out of the present moment with me just for a second. Leave behind today's emails, today's traffic, today's worries. Take a deep breath and step forward into a deeply immersive world of discovery.
The year is 2071. You've just walked into a massive, glowing interior, actually inspired by the breathtaking real-world architecture of Dubai's Museum of the Future. Walking through, the air feels perfectly climate-controlled, and it's vibrating with this low, resonant hum of clean energy. The walls themselves almost seem to breathe, curving seamlessly around you without any harsh angles, kind of mimicking organic cellular structures. Above you, natural light filters in through windows shaped like elegant Arabic calligraphy. The sheer, immense scale of the room makes you feel wonderfully small, yet entirely connected to something far greater. The design philosophy here is form follows content. What that means is every single inch of this space has been custom crafted to translate abstract, highly complex scientific concepts into a tangible, deeply emotional physical journey. And we're going to explore 4 distinct rooms today.
All right, Room 1, the Aerochromatics Wardrobe.
Okay, let's dive into this, our very first exhibit. This is where the grim reality of environmental science meets everyday fashion. It's a space that completely rethinks how we navigate the invisible dangers of modern urban spaces. According to global health organizations, almost the entire global population breathes air that routinely exceeds safe quality limits. We're talking millions of premature deaths linked to invisible urban smog every single year. So how do we protect ourselves? Well, take a look. Over here we have what looks like an ordinary, static, black cotton shirt. But right next to it, you see that exact same shirt transforming. This is aerochromics. It's a brilliant line of wearable technology designed by Nicholas Bentel. Instead of wearing a clunky anti-pollution mask or lugging around a bulky air quality sensor, the clothing itself acts as a reactive environmental monitor. It takes a basic item we already use every day, our clothes, and transforms it into a vital survival tool.
Now, what's really interesting about this slide is how specific and highly visual this data becomes. These shirts don't just tell you the air is generally bad, they tell you exactly what is poisoning it. If you encounter carbon monoxide, which is a deadly, colorless, odorless gas, the shirt reveals these bold black blobs. If you walk through heavy particulate matter, like microscopic smog and dust, white polka dots emerge. And if you're exposed to radioactivity, this coral-like pattern of white squiggles appears all over the fabric. Now, these patterns actually start to activate when the air quality index hits 60, which is considered moderate pollution, and they are completely revealed at an AQI of 160. To put that into perspective, an AQI of 160 is officially categorized as unhealthy. For an average person, breathing that air means decreased lung function, aggravated asthma, and serious respiratory irritation. In fact, particulate matter at this extreme level is literally tiny enough to bypass your respiratory system's natural defenses entirely and enter your bloodstream directly, putting immense stress on your heart.
So, for our science lovers, let's look at the microscopic magic that actually makes this happen. How does a seemingly simple shirt know carbon monoxide is present? 2 words: chemical oxidation. When that deadly gas touches the clothing, it reacts with carefully engineered chemical salts embedded directly into the fabric's threads. Specifically, these dyes use highly reactive transition metal salts, usually iron or copper-based compounds. And this isn't some slow, gradual fade either. The reaction is almost instantaneous. The second the carbon monoxide concentration crosses that dangerous threshold, the gas is oxidized into carbon dioxide. At the exact same time, the chemicals in the dye are reduced, meaning they rapidly lose oxygen atoms. This instantly snaps the dye's color to black, warning the wearer to get out of the area immediately. Once you're safe and the carbon monoxide clears, the metal salts just steal oxygen right back from the clean air, and the shirt naturally returns to its original color.
It is an absolutely brilliant fusion of organic chemistry and functional fashion. So that gets you thinking. If we can engineer a single piece of cotton to intelligently respond to its environment, what happens if we scale that technology up to the very foundations of a massive city?
Which brings us to room 2, the living infrastructure.
We all know potholes are the worst, right? Every single year, road cracks cost millions in municipal repairs and create massive logistical nightmares. I mean, the UK alone produces over 20 million tons of asphalt annually just to keep up. But researchers have developed a mind-blowing solution using artificial intelligence and biology, and it works in 4 distinct steps. First, the sticky black bitumen in standard asphalt naturally oxidizes over time. It hardens, and inevitably it cracks. Second, scientists step in with Google Cloud's AI. Now, traditional lab trials require synthesizing a chemical, physically testing it, failing, and starting over, a process that takes years. But AI acts like a hyper-speed virtual laboratory, simulating millions of complex molecular interactions in seconds to find the perfect binding agent. Third, based on all that AI data, they introduce natural spore microcapsules and waste-based rejuvenators right into the asphalt mix. These microcapsules are essentially tough biological shells containing dormant bacteria. And fourth, this is the crazy part. When the road cracks, water seeps in, which wakes the bacteria up. They feed on the waste and excrete calcium carbonate, which is basically limestone. The asphalt literally stitches its own microcracks back together in under an hour.
And listen, this isn't just science fiction. As Dr. Francisco Martí-Martinez from King's College London points out, by mimicking the deeply evolved regenerative abilities of trees and animals down at a molecular level, we can create net-zero, hyper-durable infrastructure. Working alongside materials experts at Swansea University, this technology takes a bottom-up molecular design approach to eventually completely eliminate the need for manual, disruptive road maintenance. The city of the future heals itself.
Now, let's move to room 3, the Biosphere Lab.
Let's move to and see how this builds. In the Museum of the Future, this area is affectionately known as the Heal Institute. It's where we look beyond our urban centers and focus on the entire planet. To protect our future, scientists use a truly fascinating predictive tool called speculative evolution. As one enthusiast beautifully described it, it's when you take something weird and wild, then you make it work. By applying strict scientific concepts like biology, physics, and genetics, researchers make educated, highly logical guesses about how species will adapt to rapidly changing climates. Take a speculative creature. For example, imagine a desert lizard living on an Earth that has suddenly become 3 degrees hotter. Using this scientific framework, researchers might predict this lizard evolves highly reflective, mirror-like scales to deflect the intense solar radiation and elongated legs to keep its body further away from the scorching sand. It's a creative, scientifically rigorous prompt that forces us to deeply understand the engine that drives all life on this planet.
And the scope of the work happening here is monumental. First, the primary goal is repairing damaged ecosystems right here at the Heal Institute. Second, we're exploring exobiology to imagine the parameters of life on other planets. Third, using that speculative evolution we just talked about to predict future animal adaptations. Now, how do we ground all this theoretical work? By leveraging real, concrete data from NASA's Goddard Space Flight Center. Goddard manages more than half of NASA's robust Earth Sciences program. They're constantly observing and modeling our changing climate. So we take the precise atmospheric data beamed back from these actual satellites and we feed it into our speculative models. We are literally using the hard facts of today to mathematically predict the biology of tomorrow. In this room, you aren't just looking at data. You're recruited as a pioneer at the fictional OSS Hope orbital space station, tasked with using this knowledge. We've seen shirts that warn us of invisible poisons. We've walked on roads that heal their own structural wounds. We've looked at how NASA data and evolutionary biology can predict the future of life itself. But as we prepare to enter the final room of our explainer, the atmosphere kind of changes. The lights dim.
Room 4, the final reveal.
Pixar's storytelling rules tell us that the heart of the story is the absolute most important part. You admire a character for trying more than for their successes. Throughout this entire museum, we've laid out the immense struggles of humanity: climate change, urban pollution, infrastructure decay. So I have to ask you, looking forward into the unknown, what will be the greatest, most transformative invention of the next century? What is actually going to save us?
As you step up to the pedestal in the center of room 4, there is no futuristic gadget sitting under the glass. There's no magic pill. There's just a glowing mirror reflecting your own face right back at you. The greatest invention of the future hasn't been built yet, because you are the one who is going to build it. As Dubai's Sheikh Mohammed bin Rashid Al Maktoum stated so perfectly, the future belongs to those who can imagine it, design it, and execute it. It isn't something you await, but rather create. This entire journey, From the microscopic chemistry of a dyed cotton shirt warning us of danger, to the AI-generated bacteria healing our concrete, all the way to the orbital satellites tracking our vast biosphere, it all proves that human ingenuity is boundless. We are not passive spectators in the story of our planet. We are the active co-authors of tomorrow. The tools are here. The science is incredibly real. Now it's completely up to you to take what you've learned and start building. See you in the future.